Yeah,
All right.
yeah.
We just started recording. As you may know, this meeting is recorded and will be uploaded to public internet. So, Wang, please go ahead and ask your question. You wanted to ask some questions about equivalence class.
Because I have done most of the work, but I find that because I will operate in equivalence class in the queen or and the scheduler, but it will have the low performance because of the lock.
I see. So are you talking about that first version of equivalence class, or you're talking about the more recent one that you've done?
More recently.
Okay.
Yeah.
Okay. So you've implemented that and you've noticed that it actually causes slowdown because of locking. Is this the new implementation that I suggested with that one map that has basically information or maybe keys for unschedulable pods?
Yeah. Yes.
I see. I see. Yeah. One of the issues that we've seen in the past has always been the case that adding more shared data structures such as a map could potentially cause a slowdown. It's a little bit unfortunate that this one also causes a slowdown. So let me think. Okay, for the information of others, what we are doing here is that once the scheduler finds out that a pod is unschedulable, it looks at a pod, and if it has a parent reference, which essentially means that a pod belongs to another collection, like, for example, a replica set and so on, it will add that parent reference as the key to a set. What it means is that, and this set basically is a set of pods that are potentially unschedulable. Well, not potentially, they are unschedulable. So it means that all other pods which belong to the same collection will also be unschedulable because they share the exact same specifications. So all those pods will be unschedulable unless something changes in the cluster. So what we did for this particular design is that we add this reference to to a map to cache it basically, or to a map or a set. In Go implementation, we don't have a set, but essentially this is a set. We don't store any particular value for it. But anyway, once this key is in the set, it means that all other pods which are from the same collection will also be considered unschedulable. This is a performance improvement because the scheduler does not need to check all the other pods in the collection. It can just look up the map and figure out that, okay, this other pod is also unschedulable because it shares the same exact parent. One of the issues that we are seeing now is that checking this map at every schedule cycle causes a slowdown because we need to acquire a lock to access the map. So a couple of suggestions for this. One potential suggestion, you may want to consider using a sync map. Sync map is one of these maps in the Go implementation, which is apparently more efficient compared to acquiring a lock over a regular map. I don't know if you have tried that one, but that might help a little bit. If it doesn't, we need to revisit this. I don't have any great suggestion right now on top of my head, but I can take a look. Another thing that I was thinking is that, do we actually need to acquire a lock to access this map? The reason that I'm saying this is that the scheduler accesses this map in its single-threaded main loop, right? And it only adds to the map in its own single-threaded main loop as well. So it may not require any locks.
But when I move the post to active queen, I will delete the map.
Yeah, yeah, you're right. Okay, yeah, the deletion is a problem. You're right. So, okay, so again, for the information of others, um, when another event happens in the cluster that could potentially make pods schedulable, we need to remove all these entries from this set so that the scheduler retries the scheduling some of these pods. Um, Once the scheduler determines that these are still unschedulable, it will add them back to the set. But we need to remove these entries at some point, and that point is the fact that an event happens in the cluster that potentially makes pods schedulable. So an example of such events is deletion of a pod from the cluster or addition of another node to the cluster and things of that sort, which happen in parallel to the main scheduling loop. That requires locking. You're right. You're absolutely right, Wong. I can take another look and see if we can find any better solution for this. But thanks for working on it, and thanks for sharing the problem with us.
Sure. Maybe I can try the SIG map first and to see the result.
Yeah, that would be probably something relatively easy to do because you just need to replace the existing map with a sync map and remove the locking. Sync map provides locking itself. Maybe that could potentially help. Yeah.
Yeah, sure.
Thank you for the update. Okay, I also have a good news. Today, our scalability results are in, and we hit a pretty aggressive goal that we had to schedule 100 pods per second in a 5,000 node cluster. So this is actually great. This was the result of multiple algorithmic optimizations that we made to the scheduler in the past 6 months or so. And the last one of them was one PR that got merged recently, basically just yesterday. And today's results were pretty promising. So we actually see that the average in our scalability results hits 100 pods per second. And that's our rate limitation. Essentially, the scheduler might potentially even exceed 100 pods per second. But because of this rate limitation that we have in our scalability tests, it cannot really go beyond 100. But if that rate limitation is lifted, it could potentially even go beyond 100 pods per second. I am trying to work with the scalability team to maybe raise that rate limitation because going forward, if we make any further optimization to the scheduler, we will not see the results. We need to have this rate limitation completely lifted or at least raised to a larger number so that we can keep observing our improvements. Also, if there is a change that reduces performance, but if it reduces performance marginally, for example, since we don't know whether we achieve 110 pods per second or not, if there is a performance degradation that reduces us from 100 pod per second, 110 pods per second to 100 pods per second, we will still not see it. So for all of these reasons, it's necessary for having that rate limitation lifted. We will see where we can go with that, and hopefully the scalability will be able to help us with changing that rate limitation. There was another PR. Oh, sorry, Wei, go ahead.
Yeah, that's really a milestone.
Yeah. All right. So there is another PR that Wong had sent out. Thank you very much, Wong, for that PR. That one is to basically not update the API server every time that the scheduler tries scheduling a pod and determines that the pod is unscheduled. Recently, we actually made this change that every time that the scheduler finds out that a pod is unschedulable, it adds the timestamp to the pod. This timestamp is then used in our scheduling queue to sort pods which have the same priority, basically pods which are more recently retried go to the back of the queue. This is like a fairness improvement. mechanism in the scheduler. But updating the API server at every scheduling cycle is not necessarily efficient, especially in larger clusters with many unschedulable pods. This eats up a lot of our bandwidth to the API server. I was just telling you about that rate limitation that exists. That rate limitation applies to any request that we send to the API server, including requests to update pod status. So it's important to save that bandwidth as much as possible. And this PR that Wang has sent and is almost ready, I had just a couple or like several minor comments in it. So it's going to be merged soon. Is going to remove that recent change that updates the timestamp of a pod after every scheduling attempt. Instead, it keeps that timestamp in the scheduler internal state. There is really no reason to update the API server about this timestamp. This timestamp is something that is only valuable to the scheduler. So hopefully this will emerge soon and will improve further the efficiency of the scheduler. These are, I guess, some of the updates that I had. I believe, Klaus, did you add another item to the agenda? I believe you have something there that you want to talk about, right?
Oh, yes. When we try, recently we try to reuse some property in the default scheduler. Now, when we try to use the image locality property, we found that it's dependent on the metadata, and we only depend on the total node number in this property tag. But when we build metadata from the factory, we have to pass several lister, side lister, service lister, and maybe some other lister. So yes, so I think maybe we can enhance such kind of enhance this factory. Maybe I don't have any solution right now, but I'd like to raise here is that maybe we can simplify the interface. So for example, if some user just want to one prioritize, and this party only depend on maybe one or two metadata in the meta. So we can have some way to build that easily.
I see.
Yeah.
So does this require changing the interface for all of our priority functions?
I don't think so. The draft idea in my mind is that at least we can do some skip. For example, we can skip to initialize the metadata in the metadata if we don't have for example, if we don't have lister.
If we don't have any lister, we cannot have any metadata. Oh, I see. Because
because we only, for example, for image locality, we only need node number, total node number.
Right.
Yeah. For the other metadata, we don't need that. So if we don't give there enough information, the metadata factory is still good enough to build it.
Yeah. Every time that something like this comes up, I think why we don't have the scheduling framework yet. A lot of those issues would have gone away by sort of automatically by the framework. But you're right. I see your point. I don't have any great solution at the moment on top of my head either, but this is worth exploring. We should take a look and see how we can improve the situation.
Yes.
All right. So it looks like Wei also has an update for us. Thank you very much, Wei. Wei has added a new cap for evenly distributing pods in an arbitrary topology. So this is actually an effort that we've recently been working on. The idea here is that the idea here is that we want to distribute a number of pods in a particular topology domain. A topology domain, for example, can be a zone or multiple zones, or can be even a node, can be, I don't know, region or whatever, depending on what labels you put on your nodes. Today we have anti-affinity. The problem with anti-affinity is that once you put anti-affinity on, let's say, your pods, then you basically tell the scheduler to not put more than one of such pods in that particular topology that you have defined in the anti-affinity rule. For example, the topology can be node. By saying that you have anti-affinity, you tell the scheduler, don't put more than one pods of this type on a node. Now, let's say that you have 5 nodes in a cluster, you have tens of such pods. So putting anti-affinity on pods causes 5 of them to not get scheduled at all. Oftentimes, actually, users want to achieve distribution instead of just having anti-affinity, really. In the case that they have like 10 pods and 5 nodes in the cluster, they oftentimes want to have like 2 pods on each node, not necessarily 1 pod and 5 of them getting on the schedule. So we're trying to address this problem by adding a new feature to Kubernetes where users can specify a topology, very similar to anti-affinity, but this is basically the difference between this and anti-affinity is that this one tells the scheduler to distribute pod evenly in a particular topology. So Wei has added a KEB recently. I am trying, okay, let me copy the link to our meeting notes. Oh, no, Wei has already added it. Okay, thank you, Wei. After this is merged and implemented and merged, we may revisit the anti-affinity. Today, anti-affinity is one source of scalability issues in the scheduler, as many of you know. We've been trying to address this, and we have achieved quite so much. As you may be aware, we have achieved over 100 or close to 120x performance improvement for that feature. But the feature was 1,000 times slower than many of other scheduling features. So even after 120x performance improvement, we are still like 8 to 10 times slower than other features. 8 to 10 times is still a pretty large number. Most of the reason for this slower performance of the feature is because it's very, very flexible. We have anti-affinity. Basically, once we have an anti-affinity, a pod with anti-affinity in a cluster, then every other pod that is being scheduled, we need to check it and make sure that the anti-affinity rules of the running pods are honored. So we are changing this. Well, we're not changing it yet. We are thinking about changing it so that we only provide anti-affinity on the same node, not necessarily in any arbitrary topology. And then we add this new feature to evenly distribute in arbitrary topology. The reason, basically our reasons for making this change is that most people really want to use anti-affinity in arbitrary topology domain to achieve even distribution of their pods. So once we have another feature which provides even distributions, we probably won't need to have anti-affinity in arbitrary topology domains. And anti-affinity on the node would most probably be enough for pretty much all use cases. So these are some of our reasons for revisiting the anti-affinity.
Due to this, I also emphasize in my cap that right now we just on purpose limit the topology to some, for example, node for pod anti-affinity in the cap. And also for pod affinity, I also describe the schematics of even pod spreading in the pod affinity. Also, I suggest to initial implementation also apply to node only. And also for node affinity, I also.
So initial implementation of evenly distribution or initial implementation of affinity and anti-affinity?
So basically, I try to apply this on the 3 affinity term directory we have: node affinity, pod affinity, and pod anti-affinity. But for the latter two ones, pod affinity and pod anti-affinity, I suggest to impose only on node.
I see.
Because of the performance concern.
Right. Makes sense. All right. Thank you very much. Yeah, I will definitely take a look at your KEP. Other people who are interested, please go ahead and take a look at that. The link is in our meeting notes. All right, we are 24 minutes in our meeting. I don't have any further updates for you. The only thing that I want to mention is that this week is a little bit tough for me. We are at Google. We are in this like performance review cycle. So most of us are busy with other stuff. So I apologize for not being very responsive and reviewing all your PRs in a timely fashion, but I will get to those. I know I owe you one review for one of your PRs, and also I will review your KEP very soon.
Yeah, that's totally fine.
All right, is there any other questions or comments? Yeah, go ahead.
Yeah, I just want to emphasize that an idea in my KEP that, so originally when we think about this pinpoint, right, from a customer, I propose original proposal named max path per topology, right?
Yes.
But we exchange a lot of ideas, and finally we think that ideas, you have to define a specific number. This is pretty challenging for the user, right?
Yes.
For them to tune or something, right? So
yeah,
right now,
it doesn't work really. I mean, if you think about real use cases, providing a max is not going to really be useful. And that max was essentially our reaction to the fact that users wanted to achieve even distribution. And
so for improvement, so I introduced a kind of a value called max skew. Max skew describes the degree of imbalance of the paths spreading in the cluster. For example, the default value, we will put it for 1. That means for 10 paths applied on the 5-node cluster, the deployment rollout could be 1 on each node, and the 6th one, for example, is deploying on the 1st node, and the 7th one can only be deployed on the rest of 4 nodes. That's the.
So is this really required? Why don't we just add 1? I mean, why don't we remove this whole idea of having a particular number and just
because I want maybe still give the flexibility. For example, the distribution can be, for example, 2/0 for some instances if they want, or for example, if right now the distribution is 2/1, right? If the skew value we set is 1, then it cannot be 3/1. It can only be 2/2, right? The max difference between the describe the imbalance. So we will see. Of course, if we hardcode it to 1 and only provide a Boolean value to users, it's more easy for us actually.
No, this is. I actually like your idea. I thought that you are. I didn't actually get it that you are doing a skew value. I thought that you are adding a number that specifies how many pods exist.
No, it doesn't describe the abstract number of totally. It's just describe the difference, the max difference. Yeah.
Right. That makes sense. Okay. Thank you very much. That's a good idea, actually. All right. We have 2 more minutes left. Is there any other questions or comments? Going once? Twice? All right. Thank you very much for attending. I will see some of you folks next week.
Okay.
Bye. Bye.